All right. Good evening. Good evening to one and all. Guys, I'm actually at this present moment looking at a few things, and what seems to be raging in my mind right now is the topic of, it's a grade 11 topic that's raging in my mind, and it's financial maths to be specific. I don't know who all is here, but if I can just see what grades do we have here, what people do we have here, and maybe depending on who's here and who's here, what's here. All right. I'd like to just give some attention right now to the lower grades, but I'm intending to have a grade 12 live session at 10 o'clock. So yeah, for now, if the grade 12s can sort of hold off, but if there be any other grades that are below that, yeah, I'm here for that specifically. So let's see. I think it's grade 11 financial maths, yes. Yeah, grade 11 financial maths. Okay, alright, so yeah, so we're gonna look at some finance for grade 11. Okay, let's go over some the formula that we have for financial maths in grade 11. Let's check if people actually have their formula down, because I think one thing for sure is that with the grade 11 financial maths, much of that for grade 11 financial maths is coming from the grade 10 financial maths and the grade 9. Grade 9s do financial maths, and they do a few things there in the grade 9 syllabus and in the grade 8 syllabus, which are very foundational to grade 11. Okay. Okay. So let us go forth. Okay, so if we can just summarize, because in summary we have simple interest, right? Simple interest, which obviously has this formula: A is equal to P into 1 plus I times N. Okay, this is the simple interest formula, and remember, this is interest that is calculated based on the original amount. Okay, interest that is calculated based on the original amount. So if we were to be practical about something like this, and I just want to kind of make a point here about interest that is calculated based on the original amount. Let's say I had 10 Rand. Because you see, when we talk about 10 Rand, at least we are talking about money that many of us are familiar with. Okay, let's say I had 10 Rand, and let's say I invest 10 Rand now with the intention of actually saving that amount of money. So 10 Rand is invested at 10% per annum simple interest. Okay, so this is a hypothetical example because it's literally being thumb-sucked as I speak. So let's say 10 Rand is invested at 10% per annum simple interest, right? Let's say for 3 years. And so what I want to find out, how much will be in the account after 3 years. So what I want to do here, yes, 10 Rand is invested at 10% per annum simple interest for 3 years. And the question is how much will be in the account after 3 years. All right, so yes, and so good, as you have said, in other words, the accumulated amount. All right, but I want us to kind of like understand what we mean by the fact that simple interest is interest that is calculated based on the original amount. Okay, so I know that every single, as it says, per year, every year, we are actually going to be gaining, all right, or my savings account is going to actually have added onto it every year 10% of this amount. All right, okay, and so let's say year one, this is how things look like in year one. So if we are going to calculate what is 10% of 10 Rand, okay, that's like saying 10 over 100 times the 10 Rand. Now 10% of 10 Rand is actually 1 Rand, right? So that means at the end of the first year, what's going to happen is I'm going to have 11 Rand in my account. Does that make sense? Okay. Year two, because this is simple interest, I'm still asking what is 10%, okay, of 10 Rand, which is still 1 Rand. Now remember, I have 11 Rand that is going to be forwarded into the beginning of my second year, and at the end of that second year, do you know how much money I would have made? Once again, we are going to add a 1 Rand, which means I'm going to have 12 Rand at the end of the second year. And so in year 3, as the year begins, I have 12 Rand as I begin the year, but I'm still going to be asking what is 10% of what? Of 10 Rand, which is still a Rand. So that means, in essence, after 3 years, I am going to have how much in the account? 13 Rand. So I hope that makes sense. So that's why when we talk about simple interest, we are talking about interest that is calculated based on the original amount. Okay. I hope that makes sense. So simple interest that is calculated based on the original amount. And we are always checking, all right, what is 10% of that amount that we began with. In year 2, we are still asking what is 10% of that amount that was originally put into the account. In year 3, we are still asking what is 10% of that original amount that was put into the account. And so year after year, the account grows. It grows by a constant amount, okay, which in this situation is 1 Rand every year. Okay, so there's like a constant amount that this account that I was speaking about here grows by, and it's a Rand every year. Okay. So we need to have this conceptual understanding of simple interest, because when we do, then the calculations make sense and we understand what is actually happening. All right, so that is why if we represent simple interest graphically. N, which represents the number of years, sorry, can you hold on? Okay, sorry about that, guys. Okay. All right. So back here to this whole concept of financial math. So what I was saying is that with simple interest, you need to understand that simple interest has to do with interest that is calculated based on the original amount, okay? And then basic to it, okay? If I was to just talk about an amount of money that we are familiar with, like 10 Rand, if you were to invest 10 Rand at 10% per annum simple interest for a period of 3 years, for instance, then the question is how much will be in the account after the 3 years, right? So if we want to see practically what is actually happening before we come here to the formula, let's go and check practically what do we mean by simple interest. Okay, remember I said it's interest that is calculated based on the original amount. So if you look at 10 Rand, this 10 Rand amount, we are always going to be asking ourselves, what's 10% of 10 Rand? So 10% of 10 Rand when calculated is a Rand. Okay, so that means this account is growing by a Rand. But you see, the thing is, if we go to the second year, we are still asking ourselves, what's 10% of that 10 Rand, that original amount? It's still a Rand. In the third year, when the third year begins, we are actually still asking, what is 10% of 10 Rand? So this account, which is based on simple interest, is basically going to be growing by a constant amount, which is 1 Rand. So that's why we say that simple interest, right, if we were to represent it graphically, is a linear, it's a linear function, if you want to call it like that, linear function, in that here on the x-axis we have the period, and then here on the y-axis you are going to have your actual amount. Okay, obviously here we have the principal amount, so that's when the investment begins, and then over time you will have what we know as the accumulated amount. So after a certain period of time has passed, this amount growing by a constant amount, because it's a linear progressive sort of like a formula. This is how we would see the progression of this simple interest related situation. So graphically, this is how we would basically represent simple interest. So that is why then we make things very easy for ourselves, and we talk about this formula. This formula, guys, surely you guys know that A means accumulated amount, or the accumulated value. This is obviously after a period of time has passed. Okay, that's your A value. It's the accumulated amount. It's a future value after a certain period of time has passed. That's A. P is what we refer to as the principal amount. Okay, principal amount, in other words, it is the amount at the beginning. Okay, so remember, two situations here. We could either have a savings account situation where we are saving money for a future period of time, or we could also be looking at a loan amount. Okay, yeah, at a loan amount. Okay, so principal amount, okay, that's P. N, it represents time period, and preferably in years, okay, for this formula. And then I is our interest rate. Okay, but this interest rate, guys, is a decimal number. Okay, not a percentage, a decimal number. So we actually use this formula, right, where we say the small letter I is equal to R over 100. This R here is the interest rate as a percentage. Interest rate as a percentage. Okay, very important. So A is the accumulated amount after a period of time. P is the principal amount, it's the amount at the beginning. Okay, whether it's an investment, then obviously it's an investment, it's the amount at the beginning of the investment. If it's a loan, it's the amount at the beginning of the loan, okay, period. Then N is equal to the time period, preferably in years, and then I is the interest rate. It's the interest rate as a decimal number, guys, as a decimal number. So whenever we represent I, we actually take the percentage and we divide it by 100 and we get the interest rate as a percentage. So the interest rate, sorry, okay, as a decimal number. But remember, guys, the R here is the interest rate as a percent. So that's very important. So grade 11s, very important that you guys are able to understand what each of these variables actually mean. Okay, so this is the formula. A is equal to P brackets 1 plus I times N. Very important formula for calculating simple interest. So instead of looking at this simple interest problem that I made up, because remember, this was supposed to help us understand the concept of simple interest. Now we can actually utilize a formula. This formula is always provided in the formula sheet. So remember, my situation was that of 10 Rand invested at 10% per annum, simple interest for how many years? For 3 years. The question is how much will be in the account after 3 years. So we did check year after year how much the account would eventually have, and we found that after 3 years, you would have 13 Rand in the account, if we look at the year for year progression as applying the interest rate, which is 10%. So if we use the formula, guys, very straightforward. We just take here, we know that our P value, which is the principal amount, the amount at the beginning is 10 Rand. We then say 1 plus I, the interest rate as a decimal number. Remember, we said interest rate is 10%, so we say 10 over 100, and then we times that by N, which is the number of years, which is 3. Then we just grab our calculator, we punch all of this in, and guys, you should be able to see the wonderful answer, which is actually 13 Rand. Okay? Yeah. So really and truly, we can use the formula. It helps with us being able to get the answer directly. This here, what I did here was so that we could understand the concept of simple interest, that indeed it is interest calculated based on the original amount. And so year after year after year, our investment is growing by a constant amount because interest is added year after year of 10% of the original amount. So you're able to see that indeed it's growing by that constant amount. So when we use the formula, it's very straightforward. We are able to calculate what that amount is. Now, a follow-up question to this would be, how much interest was paid into the account? Okay. How much interest was paid into the account? Now, remember here, we calculated how much will be in the account after 3 years, which was obviously calculating the accumulated amount. This question is slightly different because it's asking how much interest was paid into the account. In other words, how much money did we make after the 3-year period? Okay, at the end of 3 years, how much money could we say we actually did make because of this investment? So remember, we invested 10 Rand, okay, and then after 3 years we found that in our account we have 13 Rand. So the question now is, how much interest was actually paid into the account? How much did we gain by actually saving our money into that account that actually gave us 10% simple interest per annum? So then when we do that, guys, the interest paid is always equal to the accumulated amount minus the principal amount. Okay, yeah, that is one way of calculating the interest paid into the account. Or the alternative, in grade 8 and 9, guys, this interest paid was also having a formula which basically went the following way. It went I is equal to P times I times N. All right. Some people may have known this formula to be I is equal to P times R times T over 100. These formulas, these two, are obviously the same, these two. All right. But in essence, you want to calculate the interest that was paid into the account. So when you actually want to calculate the interest paid into the account as a grade 11 learner coming obviously from grade 10, what you want to do is you want to actually, one, you can either take the accumulated amount, which is 13 Rand, and minus the principal amount, which in this case is 10 Rand. So the interest paid, okay, is simply this amount. It's 3 Rand. We made 3 Rand. 3 Rand was paid into the account, and that's that. Okay, so this is one way of calculating the interest paid into the account, or the amount of money made after 3 years. Okay, one way of looking at how to calculate interest paid. Or alternatively, all right, you in grade, I think 8 and 9, this is the formula that they should have exposed us to if we want to calculate interest paid, you know, especially if it's simple interest, guys. So what you would do here is you take the P, which is the principal amount, 10 Rand, times it by I. Remember, I is the interest rate as a decimal. So obviously this I is the same thing as saying R over 100. Remember, what did I say about I? I is R over 100. Okay, so that's why I'm saying these two formulas are actually the same. They are the exact same formula. Okay, but your I can be written as 10 over 100. Then you times it by the number of years, which is 3. So I'm sure, guys, if you were to actually calculate this, all right, calculate it very well, all right, 10 Rand, which is the principal amount, times the interest rate, all right, which is 10%. When you say so, we say 10 over 100, we times that by 3, all right. Then we should be able to get the interest paid, which is 3 Rand. Same thing here. This here would be 10. The R would be the percentage times what? T, which is the time, or the time period, which is 3 over 100, which also will give us what? 3 Rand. So if you have simple interest, guys, as your focus, right, it is so important to be able to find the interest paid, you know, versus the accumulated amount that your account would actually have after a certain period of time. So very important formula there. And also, please, guys, for the sake of calculating interest paid, we need to also know these two important formulas. Either when we have the accumulated amount, we subtract the principal amount, or when we have the principal amount, the interest rate, and the number of years, we can always substitute into that formula and get the interest that was paid into that account. Now, you will also know that apart from that, you also need to know how to calculate situations where you are given A and they're asking you to calculate P, or where you are given P and you are asked, you are given P, you are given A, you are asked to calculate I. You know, all of those need your algebra skills, you know, of calculating. Okay, and when you are able to do that, really and truly, it is not that difficult to move. So that was simple interest. Now I want to move on to compound interest. Okay, I am looking at the concept and I'm looking at the formula and unpacking the formula. Now, what is compound interest? Guys, compound interest is simply interest on interest. Okay. It is interest that is calculated based on interest on interest acquired previously. Okay, so I'm going to go back to my 10 Rand scenario so that I can actually spell out for us how compound interest works. So let's say we have 10 Rand invested for a period of 3 years again. Okay, period of 3 years, and then we say it has a 10% per annum compound interest applied to it. Okay, so I hope you guys understand here. So we have 10 Rand invested for a period of 3 years, right? Then we are told it has 10% per annum compound interest applied to it. So 10% per annum compound interest is applied to this particular investment. So then the question is, how much is in account after 3 years? Okay. So compound interest, like I said, is interest on interest. So how it works, I want you to just look at year 1. So in year 1, what happens is we are going to say, remember, we are investing 10 Rand. This is the interest rate. It's 10% per annum, and it's compounded. Okay, it's compound interest. So in year 1, we are going to say, what is 10 Rand? What is 10% of that 10 Rand? So I'm sure you guys know what's 10% of 10 Rand by now, because you just did a situation where there was 10% of 10 Rand. So that means you are going to say 10 Rand times by 10 over 100, which is basically 1 Rand. So that means when that year is finished, we are going to have how much money? Remember, you had 10 Rand, you add a 1 Rand, it means you are going to have 11 Rand. Okay? But here's the thing, guys. This is what happens, and this is where it's different as simple interest and compound. So in compound interest, when we go on to year 2, we say, what is 10% of now? Not the original amount, but the grown amount. The previous year's amount. So we are going to say, what's 10% of 11 Rand? Now, of course, I'm sure you guys know what's 10% of 11 Rand. In other words, what's 10 over 100 times 11? I'm going to wait for someone in the comment section to actually tell me what's 10% of 11 Rand, so that I can see that you guys are actually with me. You know, I have a fear that people are just watching, but they don't. They're not actually following along. So what's 10% of 11 Rand? Someone can tell me in the comment section what's 10% of 11 Rand. I'll be happy to actually plug it in. 10% of 11 Rand, going once, going twice, going 3 times. Silence. No calculators. I'm Luto, 90.9. How can it be 90.9? When are you bothering here? Okay, Ngwato says 1.1. Dokozo Nomalo says 1.21. Okay, good people. 10% of 11 Rand. Okay, so when you say 10 divided by 100 times 11, no, guys. Okay, so it's 1 Rand, and you'd say 1 Rand and 10 cents. Okay, so that means, remember, we had 11 Rand, we add 1 Rand 10 cents, that means we have 12 Rand 10 cents after the second year. Okay, makes sense? Then we go on to year 3. We say again, what is 10%? Are we going to say 10% of 11 Rand? No. Are we going to say 10% of 10 Rand? No. Are we going to say 10% of the year-end amount of the previous year? Yes. What's 10% of 12 Rand 10 cents? Okay, So you do the same thing. What's 10% of 12 Rand 10 cents? I think Ntokozo went ahead of time there, went ahead of the game, and Ntokozo is already giving us the next and the next and the next answer there. Mr. Ntokozo Ngumar. Okay, so I hope you guys can see that. So 10% of 12 Rand 10 cents will give us a 1 Rand 21 cents. Now, if you add that 1 Rand 21 cents to what? To the previous amount, which was 12 Rand 10 cents, then what do you get? You get 13 Rand 31 cents. 13 Rand 31 cents. Now, I want to do something very quickly. I want to go back to the previous, definition of simple interest, where we said it's interest that is calculated based on the original amount. If you remember, with simple interest, we had 11 Rand for the first year. Do you see that? Even for compound interest, you have 11 Rand for the first year. With simple interest, second year you had 12 Rand. Compound interest, you have slightly a huger amount, which is 12 Rand 10 cents. Simple interest, we had 13 Rand. Compound interest, we have 13 Rand 31 cents. I'm sure you guys can see that year after year, compound interest seems to make more and more, compared to simple interest. Compound interest with the same percentage, all right? It's just that here it's compounded, whereas in the previous year, scenario, it is actually simple interest. So what we are seeing here is that because we are adding interest on interest and we are always calculating interest based on the previous year's amount, then obviously the growth of our investment tends to be what? Not linear, but what? Exponential. Exponential. So this is obviously our x-axis, the number of years. Then, of course, this is the amount here on the y-axis. And the principal amount at the beginning compared to the final accumulated amount after some time has passed. You can see, guys, this here is exponential. So our compound interest is exponential. It mimics our exponential function. I hope we are together here. Whereas our simple interest is a linear function, whereas this is an exponential function. So that speaks to the growth, all right, when we are dealing with compound interest. It's exponential, whereas the growth for a simple interest related scenario is linear, all right? Same constant amount, the growth is happening, whereas for compound interest, you can see there's a slight increase in the amount that the investment is growing by. So therefore, that means it is not a constant amount. That's why we say it is exponential, because there seems to be growth in the interest or the amount that we are adding on year after year, because we are always calculating it based on the previous year's accumulated amount. So that's very important. Okay. All right, we'll do leave me alone. No problem. We'll do that. Okay. I'll do that. So yeah, that is that with the compound interest. Then we could obviously go ahead as grade 11 learners, and obviously this is applicable to grade 10s. We could then, of course, use the formula, okay, for compound interest, which is A is equal to P1, okay, plus I to the power n in brackets. And obviously this formula, guys, has to do with same variables. A, the accumulated amount. P, the principal amount, the amount at the beginning. 1 plus I, the interest rate as a decimal, and n, the time period, preferably in years. Okay? And if we use the formula, instead of applying the concept, guys, remember, when you are doing the actual calculations, we don't do this. This is just for you guys to understand what compound interest is. That's why I did this year by year by year approach, so that you can see, oh, every year we are always adding on interest, but the interest is calculated based on the previous year's accumulated amount. So we can use the formula 10 rand, remember, 1 plus the I was 10 over 100, we say, and then n of course is the number of years, which basically in this case is 3. And if you put this into your calculator, you'll be able to get exactly that amount, which is what? 13 rand, what? 31 cents. And that's that, if we round out to 2 decimal places. So guys, that's it. Hi, that's it, guys. That's it. All right. So I need you guys to have a good grasp of this concept. Okay. Now moving right along. All right. Whilst we are still here on compound interest, okay, we have what we call compounding periods. Okay. What I am doing here today, I am just going over the concepts that have to do with financial maths, the things we are learning in financial maths in grade 11 as grade 11 learners. Okay. Compounding periods. Now, what are these compounding periods? Guys, compounding periods are simply the periods within a year whereby interest is added to our investment, if it's an investment, or to the loan amount if it is a loan. I repeat, what is compounding periods? It is the periods within a year, okay? Periods within the year whereby interest is added, okay? Now, I am just going to write the first one, annually. So we can compound annually, all right? In other words, this is when we add interest to the account once a year. We add interest into the account once a year. All right, this is compounded annually. So that's our first compounding period. We are very familiar with this compounding period because in grade 10, that's what we were dealing with all the time. In grade 11, we extend our boundaries and we fly a little bit higher. We don't only compound annually, but we can also compound. And I'm going to write the synonyms that have to do with this. We can compound biannually or semi-annually, because these are the other alternative words that I used, or half yearly. Okay, which basically means every 6 months. Now you can count how many times that is a year and you can do the maths. So if we are saying biannually, semi-annually, half yearly, and all of these things basically mean every 6 months, you tell me how many times a year are we going to be adding interest into our investment? If annually means once a year, what does biannually, semi-annually, half yearly, or every 6 months mean? How often am I going to be adding interest to my account? You tell me how many times, because now I want to write how many times, because you remember for annually I said once a year. Okay, annually means every year. Okay, I guess that's another way of saying it, annually, or we can say every year, which means once a year. What about biannually, semi-annually, and half yearly? Every 6 months means how many times in a year? I am waiting for you guys to answer now. Semi-annually, biannually, half yearly means how many times a year? Thank you, Samantha. You are the best. So we are saying twice a year. Twice a year. Thank you. 3, we can say we are compounding quarterly. compounding quarterly. That's another compounding period. Compounding quarterly. What does compounding quarterly mean? Okay. We say every 3 months. So how many times are we adding interest into our account? How many times? If annual is once a year, biannually, semi-annually, half yearly, and every 6 months is twice a year, what does quarterly mean? Every 3 months. Every 3 months means how many times in a year are we adding interest? How often? Hey, Samantha is on a roll there. 4 times a year. Go Samantha. Go Samantha. Samantha is just tattering everything. Okay, very good, Samantha, for you. Then lastly, right, what about daily? Daily. How many times? 365 times. So that means we are adding interest 365 times a year. Now, given, guys, that we include the leap year, how does that change the situation? If we are including the leap year, how many times does that mean? Leave me alone, you're saying hi, Samantha. Okay, DJ Aka, definitely we are going to say +1 to the 365. So that means what? Yeah, Samantha, well done. If we include the leap year, it means we are not going to say 365, we are going to say 366. Weekly. If we say weekly, what do we mean? If we say weekly, what do we mean, people? We say weekly. How many times? Samantha. Yeah, 7 days. And in a year, all right, every 7 days, obviously, very true. If we're saying weekly, we're saying every 7 days. But that actually translates to how many times a year? 52 times a year. All right, guys, this is basically what we have to be vigilant and mindful of. One last one, monthly. If we say monthly, how many times a year do we mean? Samantha is on another planet. I'm telling you, planet freedom, planet. Let's just get all the marks. Yes, monthly means 12 times. Very good. Okay, so all in all, these are the things we need to know when it comes to compounding periods, because compounding periods are utilized very strongly in some calculations that we do in the financial maths in grade 11. When we know them, it serves us well. When we don't know them, it does not serve us too well. So in our compound interest formula, A is equal to P, brackets 1 plus I times 1 plus I, brackets to the power n. This is how our formula is affected when we factor in compounding periods. Formula touched by compounding periods. Okay, remember, compounding periods will only apply to compound interest, not to simple interest. Okay, compounding periods. So our formula will be affected in the following way. Okay, we use M to basically denote our compounding period. So our interest rate will be divided by M, as well as our number of years will be multiplied by M. So the compounding period divides itself, all right, we divide the compounding period by, divide I by the compounding period. Then we also multiply the time period by the compounding period. This is how our formula is affected when we factor in the compounding period. And it's very important, guys, that we know that the interest rate, we divide the interest rate by the compounding period, as well as the number of years we multiply by the compounding period. That is how our formula for compound interest is affected when compounding periods are in effect in a scenario. Okay? All right. Now, thank you very much. Now I'm moving right along, guys. I am not really, stopping. We are moving right along swiftly. We are going to look at questions that have to do with these things, but I need to first touch the concepts, the overall concepts that are covered in financial maths in grade 11. Depreciation. This has to do with the loss of value in items. All right. Hello, ma'am. So depreciation has to do with the loss of value in certain items. Guys, you know, and I'm sure you know, that, the word D means, go down, there's, it's like when you are depressed, for instance, you are someone who's down in the dumps. The DE is a prefix that basically signifies something going down. Okay, so depreciation is the loss of value in certain items. All right. For instance, if you buy a car from a car dealer, it has been reported that the minute someone buys a car from a car dealership, the minute they drive out of that nice, sweet, good-looking venue where the car has basically been placed, the car starts to go down in the value that it has. So you may have bought it for 200,000 rand, maybe in cash even. But the thing is, as time goes by, the value of that car, it goes down. So we talk about the loss of value of items to something that we call to a book value. Now, a book value is simply the item's value or its worth after a period of time has passed. The value of an item after a certain period has passed. That's what we call the book value. The value of an item after a certain period has passed. Okay. Then we have something else besides the book value, which we call the scrap value. This is basically the value of an item This is the value of an item after a period of time when it's no longer useful. It's like it's reached its useful life, So this is what we call our scrap value. Okay, you can see even the word scrap. I can think of a car in the scrap yard, for instance. All right, yeah. So if you think about it in that way, this item or whatever that particular thing is, it still has value, guys, but it's just that we call it a scrap value. I mean, this is obviously after a number of years have passed, and in actual fact you may find that it is no longer useful, that particular item, anymore, but it still possesses a value, which is very, very interesting that it still does. So there are two types of depreciation. We have what we call simple decay, or we call it the straight line method. All right, that's one. And then the other one is what we call it compound decay. or what we refer to as reducing balance method. And guys, there's nothing really fancy here, and that is just the manifestation of these two types of depreciation: compound decay or reducing balance method, as opposed to straight line or simple decay. This is simply the formulas that we have. We have A is equal to 1 minus I times N. Now, interestingly enough, I'm sure when you look at this formula, which formula are you thinking about? You have in your head the simple interest formula, but the only difference is that instead of there being a sum to separate I1 and IN, you actually have a difference that separates 1 and IN. So that's the simple decay or straight line method formula, as opposed to what? The reducing balance method of the compound decay formula, which has this formula: A is equal to P1 minus I to the power N. Okay. Now, the only real big difference when it comes to simple decay and compound decay is that you can see this one, like simple interest, has I times N, but obviously because it's decay, there's a negative sign, not a plus sign. Compound decay or reducing balance method has 1 minus I or as well, but obviously to the power what? In brackets, to the power N. Okay. Unlike compound interest, it doesn't have plus, but it has minus. And this has to do with when we are looking at items that are losing their value over a period of time. Now, of course, then that means if you look at your A and you compare it to your P, all right, if you look at A and P, who is going to be big, who is going to be small? Remember, this is the items amount after a period of time. Remember, we would say it's the accumulated amount when we are talking about compound interest or simple interest. But now, since we are talking about decay, this means that this amount A will not be greater than P, it will be less than P. That's what we are expecting when we are talking about depreciation. A is going to be less than P. Whereas if we are talking about interest, compound interest and simple interest, then obviously A is going to be greater than P. That is the difference between simple interest with compound interest versus simple decay and compound decay. Also, let us observe what we see graphically with simple decay. An amount, this is not N, obviously this will be our P value, and then this will be our A value, right? Very important this time around, because our A value, right, will be less than the what? The P value. Very important, you see? Yeah, so it's the other way around. That's for simple straight line method, obviously a straight line. But for compound decay, please take note, guys. I want you to note what I'm going to just do now. For compound decay, if you look at the exponential function, it is never, ever going to be what? Touching this horizontal line, because it's exponential. And you remember, even when we're doing exponential functions, we know that there's an asymptote that exists, all right? So obviously this will never touch. We have N here, we have P there, we have A there, but even our A value, okay, it's not like it's going to ever reach 0, because like I said, these items will decrease in value, but they will never be like 0 rand. They will always be a certain amount, but obviously way lower than the original amount that they began as, okay? So graphically, we need to also have a visual picture of what we mean by simple decay, okay, which is the loss of value of items over a period of time. That basically is of simple, you know, that kind of, you know, and then here we have the loss of value of items, but on a reducing balance. Okay, thank you so much, Menindulu. Oh my goodness. That's very kind of you, that Rose. I really appreciate it. Okay, guys, I really appreciate whatever form of appreciation, whether that be double tapping on the screen, whether that be listening like attentively, taking down notes, like anything that will be adding value to you. All right, I feel like as I do the lives, I may think that I am depreciating in value because I am taking my time out of my valuable time, and there's many things that I'm sacrificing for that. But simultaneously, that I can add value to you guys is very important, because at the end of the day, people are saying, and I've been having many testimonies of people who have come into my live session, joined, and they've been able to learn something. And I really thank God for that. Hopefully that is going to be your story as well, because you want to change the picture for yourself when it comes to mathematics performance. Okay, so that is depreciation, guys. Okay, so these are the two formulas, all right, and it's as straightforward as that. So when we speak about straight line method, you need to understand straight line methods for what they are. When we talk about reducing balance method, you need to understand reducing balance method for what it is. And when it is asked in the question papers, you need to then apply it accordingly. The last formula I want to look at before I jump into specific problems and also look at timeline type problems, I want to look at what we call effective and nominal interest rates. Effective and nominal what? Interest what? Rates. Effective and nominal interest rates. Guys, simply put, we have a beautiful formula here. I'm not going to go too deep into this. 1 plus I effective. Okay. 1 plus I effective is equal to 1 plus I norm over m to the power m. Okay, and that's that. So when you want to calculate your effective interest rate, all right, quoted, then basically you check what your nominal interest rate they are saying about it. They usually say your nominal interest rate, and they'll tell you about the compounding period. Remember, you divide by the compounding period. You then obviously raise this exponent to that particular compounding period. And then what you do, if you want to calculate the effective interest rate, you take the 1, you transpose it to the right hand side, and then you get the effective interest rate. So we are going to check, how do we convert effective to nominal? How do we convert nominal to effective, especially when questions are asking those questions directly? Okay, so with those formulas now all known, okay, we have pretty much summarized the conceptual formulas that we utilize in financial maths in grade 11, in such a short and quick period of time. So let's now jump into some problems. Okay. And as we look at these problems, we are going to also look at timeline type related problems. So let's just patiently wait for me to be able to kind of like do one by one. We'll get to where you want, okay? Just chill and allow us now to jump in, and let's check some problems that may, obviously, we can see what happens. Let's look at this one. We are told here that Mr. Toyisi invests 3,500 in a savings account. Okay, so Mr. Toyisi invests 3,500 in a savings account. All right. The interest rate for the first 4 years is 8% per annum. You see that? For the first 4 years, it's 8% per annum. Compounded monthly. Thereafter, the interest rate is changed. Ooh. Interest rate is changing here from Mr. Toyis. Changed to 9% per annum, compounded half yearly for the next 5 years. Right? Determine the amount of money that Mr. Toyisi had in his savings account at the end of this period. Okay. Now, guys, it's very important that when we read, we must read and be sure that what we have read makes sense, so that we can then use what we call a timeline. So this question here is going to require us to use a timeline. Timelines are effective tools that we can use in financial mathematics to assist us, especially in problems that have to deal with what? Changing interest rates, and when we have deposits and withdrawals from an account that we are dealing with. I repeat, timelines are effective tools that we can utilize when we are dealing with problems in financial mathematics where interest rates are changing and where we have additions into the account within our investment period or withdrawals. So timelines are useful for that purpose. They are not in and of themselves the answer, but they are simply tools to assist us in being able to formulate the method and the system to getting to the answer most effectively. So let's look at this one more time. Mr. Toyisi does what? Invests. This is an active word in English. This is a verb. He is investing how much? 3.5 in a what? Savings account. So this is a savings account. This is not a loan. This guy is saving. All right. So obviously, when we talk about saving something, it means we are interested in there being interest, all right, in that particular account, so that we can grow our amount. Now, furthermore, it says the interest rate for the first 4 years is 8% per what? Per annum. Hey, so we have the first 4 years, and that is the interest rate. It's 8%. Are we together? I hope we are. Compounded monthly. So this interest rate is not just 8% per annum, but in that year, how many times are we adding interest into the account? It says here compounded monthly. So we have a compounding period that within each year that we are growing that account, we are going to be adding 8% per annum monthly, all right, which means every year we are going to be adding interest 12 times within a specific year. It then says thereafter the interest rate is changed. Ooh. So our interest rate does what? It changes from where? From 8% to who? To 9. But look at the compounding period. When it's changed to 9% per annum, it's compounded half yearly. So that means now all of a sudden we're not adding interest, every month. Now we are adding interest twice a year, meaning every 6 months. For the what? For the next 5 years. Remember, this is the next 5 years after this 4 years. Are you with me? Hey, guys, I hope you are with me here. Then it's saying, determine the amount of money that Mr. Toyisi had in his savings account at the end of this period. Or let's say that Mr. Toyisi has in his account, in his savings account at the end of this period. So my grade 11 learners, this is a nice question for you guys. So let's look at how we are going to apply our timeline, and then calculation will follow. Let's first draw the timeline. We know that timelines start at T0. All right. Here specifically, we are going to say T0. All right. Now, the interest rate for the first 4 years. Now, let's do that. That means T1, T2, T3, T4. First 4 years. This is grade 11, my pinkies. First 4 years. Okay. So for the first 4 years, the interest rate is what? 8% per annum. Compounded what? Monthly. So what I usually say to learners is that it's very important that at T4, you understand that for the first 4 years means from T0. Remember, T0 means, this means the beginning in our timeline. Okay. Guys, the answer will always follow. Okay, the true answer will always follow, but it's very important first to make sure that our timeline, we understand what we are dealing or what we are doing in our timeline. So T0 means the beginning. This is at the beginning of our investment. So Mr. Toy says we are told invest 3,500 in a savings account. This is where he does that. 3.5. Mr. Toy is at T0. Then look at this. Year 1, 1. Year 2, 3, 4. First 4 years is up until T4. Make sense? All right. Then this is what I want to say. Simply put, you write here your interest rate. Remember, guys, that remember I said to you that I is the interest rate as a decimal. So when you are going to be interested, what is 8 over 100? Okay, obviously 8 over 100 is going to give us 0.08. So what I love saying to my learners is that here you write 0.08. You know that the interest rate is divided by the compounding period. So how are we compounding here? The interest rate for the first 4 years is 8% per annum. So I've changed my 8% to a decimal number by dividing by 100. Now I have I as 0.08. It's a decimal number, of course. Then what am I going to do? I'm going to divide by what? By 12, because we are compounding what? Monthly. Because compounded monthly, what does that mean? It means we are adding interest every month. How many months in a year? 12. That's why when we are dealing with compounding periods, what did we say when we were talking about compounding monthly? It means 12 times within a year. So we are going to say 0.08 over 12. Then this is for my bracket, right? 1 plus I. In my I, I'm going to have 0.08 divided by 12. Then for my outside the bracket, I'm going to have my N times the M. Do you remember that? Meaning the number of years times the compounding period. Now, people, please note how many years? First 4 years. So it's 4 times M, the compounding period. That's 4 times 12, which gives me what? 48. So in my first 4 years, this is what I'm looking at. 3,500 invested by Mr. Toyisi for the first what? 4 years. So in my first 4 years, this is what I have. An interest rate, compounded monthly, the number of years, which are 4 years, times by 12, the compounding period. Okay, now let's continue. My timeline is getting full. Thereafter, the interest rate is changed to 9% per annum compounded half yearly. Let's unpack what that means. Interest rate is changed. Where is it changing? It is changing here. Okay, for the next what? 5 years. So let's go T4, T5, T6, 1, 2, next 2 years, next 3 years, next 4 years, next 5 years. I'm in T9. That's where I'm at. All right, for the next 5 years. 1, 2, 3, 4, 5. That's where I'm at. That is the end of the period. So they are saying the interest rate is changed to what? To 9% per annum. So let's go. 9%, we divide 0.09. Remember, I changed it to my decimal. But then compounding period, compounded half yearly. What does half yearly mean? It means biannually. What does biannually mean? It means semi-annually. What does semi-annually mean? Every 6 months. What does every 6 months mean? It means twice a year for the next 5 years. So I know I'm going to be dividing the 0.09 by 2. Thank you so much, Mrs. Sim, for the you awesomes and everything else. And thanks for passing by with such a shower of beautiful gifts. You are amazing. Thank you so much. Thank you so much. Then we have N times M. All right. There. For our exponent, we are accommodating this for our exponent. How many years do we have here? All right, so that's 1, 2, 3, 4, 5 for the next 5 years. Makes sense? So that means we are going to have 5 times 2, which gives us what? 10. Okay? And our timeline is going to serve us very well. This is what I want. Okay? So, I'm going to say now A is equal to P1 plus I to the power N. Now, to be specific, now I want you guys to now take note of what I'm going to do after having my timeline. Okay, because remember, I was told that Mr. Toyisi invests 3,500, there it is, in a savings account. The interest rate for the first 4 years. So from T0 to T4, these are my first 4 years. Okay, what about the first 4 years? The first 4 years is 8% per annum, compounded monthly. 8% per annum. Remember, my 8% I convert to to a decimal number by taking the percentage and dividing by 100. So I have 0.08, which is divided by 12. I am writing this in, guys, so that I can make sure that 0.08 divided by 12, because I know when I am going to be applying this into my compound interest formula, I know that if it is compounded monthly, I take my percentage, which I've expressed now as a decimal by dividing by 100, I divide by 12. But since I know for the first 4 years, the interest rate is only applying to the first 4 years, then I'm going to also, for my exponent, make sure that the first 4 years is multiplied by By 12. Which gives me 48 for my exponent. I hope we are together there. Then, remember, we were then told the following. Thereafter, the interest rate changes to what? To 9% per annum. Compounded what? Compounded half yearly. What does 9% per annum mean? It means I change now the interest rate from 8. Okay? We are no longer dealing with 8% now, compounded monthly. For the next 5 years, as it says there, we are dealing with 9% per annum, compounded half yearly. What does half yearly mean? It means every 6 months. What does every 6 months means biannual? Biannually means semi-annual. Okay, these are all the synonyms that mean half yearly. But what does it translate to when it comes to dividing my interest rate? It means I divide by 2. Why? Because we are adding interest twice a year within that year. So that's why we divide by 2. But remember, we divide the interest rate by 2, but we also do what? We multiply the number of years left by 2. The same compounding period, we get 10. Are we together? I hope we are together there. Okay? Now, to finish it off, or to finish things off for ourselves, we can do the following. We write down 3,500. We open a bracket. This bracket is being opened because the 3,500 is going to first enjoy the interest rate of 0.08%. Okay, compounded monthly. So let's show that. 1 plus 0.08 divided by 12. This 3,500 is going to enjoy this interest rate for the first 4 years. But it doesn't end there. This same 3,500 rand, okay, before we go there, the 3,500 rand enjoys the interest rate compounded monthly for the what? For the first 4 years. So there at the top as an exponent, we are going to write 4 times 12. Now, I already told you what 4 times 12 is. It is 48. Okay, so you don't have to just write 4 times 12. You can just write 48 already there for your exponent. I hope that makes sense. Because when we have a compounding period, we divide by that compounding period, but we also multiply the number of years by that very compounding period. Thank you so much, Mbali, for that gift. Okay, but this 3,500 does not only enjoy this interest rate. After it's done enjoying this interest rate, when the interest rate changes to 9%, do you know what? The same 3,500 begins to enjoy. So we open another bracket.
Why are we opening another bracket? Because once we have calculated the accumulated amount here, we then continue to take whatever amount we have gained for the first 4 years and we allow it to also enjoy this interest rate as well for this compounding period. Are we together? And then for how long? For the next 5 years. So we take the number of years left, which is 5, we multiply it by the compounding period, we get 10. So hence, you have 5 times 2. Guys, this is how we use our timeline effectively to ensure that we have one calculation written in one line, and then we take our calculator, we punch all of this in. So obviously that's 48. And obviously that's 10. And then you guys punch that into your calculator. You tell me what you get as a grade 11 then. What is your final answer? What do you get there? Okay. I think Love More had sent his response in the comment section. Do we all get, I don't have my calculator with me, so do we all get this amount? Now guys, if there's one thing that in the diagnostic report every single year is said about the learners do not round off properly. You guys are struggling with the grade 9, grade 8 concept of failing to round off correctly. So for instance, I'm seeing 2 answers here, and Tokozo Akwana says 7,477 rand 28 cents. Sorry, Love More. Okay, you're a she. I'm sorry. It's just that I know Love Mores that are males. So thank you for correcting me there. Okay. So my question then is that rounding off correct? Is it 7,400? Very accurate with our rounding off. If we round off incorrectly, then we are setting ourselves up for a loss of marks unnecessarily at the end. So what is the correct rounding off there? So Love More is saying 29, say. Okay. So Mtokozo, you need to get back to me in the comment section. Is your rounding off correct or is it incorrect? Okay. Because guys, I'm telling you now. Okay, Samantha is saying it's 285. Now guys, if it is 77,000, I mean 7,000, sorry, not 77,000, 7,400. You see now me, I'm also going cocaine. 7,477 rand 285. Remember, if we are rounding off to 2 decimal place, we cut off 28, and then the 5 we ask, what does 5 say to the 8? Remember, if the number is 5 and more, it says to the previous number, let us go up. If the number is 4 and below, it says to the previous number, let us stay the same. So please, Ndokozo, make sure that you round off correctly. Otherwise, we are going to have issues. Okay, so we are all agreeing now that the answer is supposed to be 7,477 rand 29 cents. Please guys, let us not butcher it up there at the end. Ontonda, Rapulu. Nice. Okay, thank you so much, Aiden. Really appreciate that. Okay, thank you so much. So that's timeline, usage, effective, 100%, no problem. Okay. All right. Let's check another one. Okay, Mr. January and Mr. Hlotloza are saving up for their metric dance. I know that for some people it's metric dance season. It's happening, guys. It's happening. It's flowing, you know. It's flowing like crazy. Ondonda, this is not the live session for me to be explaining outstanding balance. I have a grade 11 audience. So when I do grade 12 financial maths, okay, which is not now, and it's not going to be anytime soon. It's not going to be today, because this is me doing grade 11 financial maths. Then I'll be able to explain that. At least you guys have a variety of teachers online and everywhere, man, to actually make sure that you get that down. So don't limit yourself from actually going and venturing into the concept and understanding it properly, right? And don't wait until I do the live lesson. Please use the necessary resources to make sure that you understand that concept literally before the end of the night tonight, I think there's a mirage of resources to use to actually get there. Let's look at this scenario. Question to Mr. January and Mr. Shoshoza. Can you guys say that? I'm thinking like all the other speakers, is it possible for all of you to be able to pronounce that? Shoshoza, Mr. Shoshoza. Mr. January and Mr. Shoshoza are saving up for their metric dance. Wow, how nice. Note, take the beginning of a school year to be the beginning of January, okay, and the end of a school year to be the end of December. Okay, I hope we got that. Now listen, Mr. January has been saving up money for his metric dance since January. Okay, remember, they were told here to take the beginning of a school year to be the beginning of January, and the end of the school year to be the end of December, okay? Now, we are told that Mr. January has been saving up money for his metric dance since January in his grade 8 year. Okay, imagine his grade 8 year. At the beginning of grade 8, he puts 200 into an account, okay, giving him 8.5% interest. Okay, now let's say 8.5% per annum interest compounded monthly. Okay, at the end of grade 9, he deposits 550. Okay, at the end of grade 10, he deposits 350. And at the end of grade 11, he deposits 200. He withdraws all the money halfway through his metric year at the end of June. Using a timeline, determine how much he will have to spend on his metric dance. Okay, so let me zoom out from the question so that you guys can maybe see it in its entirety. Mr. January has been saving up money. Me, guys, I must be honest, when I have a financial maths question, it's so important for me to be able to read and reread the question so that I do not assume anything about anything mentioned in the statement. I need to be able to read those questions and read them so well. That is why, for instance, for metric learners, guys, you see, metric, those who are doing metric and those who will be writing end of year grade 11 papers, this is what I advise you guys. When you are given, because usually before you write, you guys are given your papers, they give you the paper, they give you like a good 15 minutes, I think, to actually look at the paper and to make sure that the paper is clear. If you have any questions, you can ask them, all right? But in that 15 minutes reading time, or whatever it is, you must make sure that you are able, all right? You are able in that pure, couple of minutes time. It's pure maths, NMA Ace. You need to make sure that questions like this, for instance, that will need your comprehension and your understanding, you need to go to those questions, those financial maths questions, and make sure that those questions are clear for you, all right? And then you plan accordingly before you write, so that you are able to attend to those questions well in time. Because sometimes you could miss something. When there's the pressure of the exam paper and you are actually in the midst of the paper itself and you are busy trying to jump from one question to the next because you want to complete the paper, as much as you want to be accurate, you want to complete the paper, if you don't actually make sure that these things are understood and they are interpreted well, you suffer the loss of marks unnecessarily, right? So that's why it's important to unpack this nicely. So Mr. January, I'm going to repeat this again. Mr. January has been saving up money for his metric dance since January in his grade 8 year. Since grade 8. Sherman, can you imagine? Since grade 8. All right. Then we are told that at the beginning of grade 8, what does this guy do? He puts 200 into account, and the interest rate that 200 gives him. We are told, giving him 8.5% per annum interest compounded monthly. Okay, 8.5% per annum interest compounded monthly. Okay, I hope we are clear with that. At the end, okay, so this is at the beginning of grade 8. He puts that amount into an account, giving him that much. Then at the end of grade 9, okay, at the end of grade 9, very important, that thing, what we mean by that, at the end of grade 9. What happens at the end of grade 9? He deposits 550. Okay. Then, at the end of grade 10, what happens at the end of grade 10? He deposits 350. And at the end of grade 12, of grade 11, he deposits 200. Then it says he withdraws all the money halfway through his matric. Hey, halfway through his matric. Oh my soul. Halfway through his matric, he withdraws. This guy. Okay. Using a timeline, determine how much he will have to spend on his matric tons. Okay, so let's first then check if we understand the timeline very well. We were told Mr. January has been saving up money for his matric tons since January in his grade what? Grade 8 year. At the beginning of grade 8, he puts 200. So if we draw a timeline, we can all agree that T0, he puts in what? 200, right? At the beginning. So that's T0. He puts 200 into the account. That is giving him what? 8.5% interest compounded monthly. Now, I was looking through everything, every detail there. It seems like that interest rate does not change. So that means we are going to have to accept that we have 0.085 as our interest rate. Now, let's look at the compounding period. How is it compounded, this interest rate? It's compounded monthly. So we are going to divide it by 12. And that is going to be for the entire investment period. We are going to have this interest rate. Nothing else is going to change. I hope that's clear for all of us, right? Okay, good on. Now, at the beginning of grade 8, he puts 200 Rand. So we are not going to be worrying about changing interest rate, which is great. Grade 8, he puts 200 into an account, giving him 8.5% per annum interest compounded monthly. So we've interpreted what that means. 0.085 time over 12, no problem. Then we are told at the end of grade 9, he deposits 550. Now let's interpret what does it mean at the end of grade 9. This is the beginning of grade 8. T1 will be the end of grade 8. The beginning of grade 9. T2 will be the what? The end of grade 9. I hope that makes sense, guys. I hope you understand this. This is the beginning of grade what? Grade 8. This would represent the end of grade 8, but the beginning of grade 9. But remember, they are saying here, at the end of grade 9, he deposits 550. So where are we depositing 550? We are depositing it 550 at T2. Okay, I hope you guys, I hope you are with me here. I hope I'm not losing any of you here with what I am saying. Okay, yeah, because as I was reading the statement the second time, I actually kind of wrote tentatively the timeline based on what I was understanding. So I hope you understand what I mean. Okay, that end of grade 9 means 550 at T2. Then at the end of grade 10, he deposits 350. So here we are at the end of grade 9, which means at T3 we are at the end of grade 10. Deposits how much? At the end of grade 10 he deposits 350. So we are adding another 350. Let's go. At the end of grade 11, which means at T4, he is going to deposit how much? Deposits 200. So we are adding a 200. And then lastly, he withdraws all the money halfway through his matric. Right? Remember, we are at the end of grade 11, the beginning of grade 12, which means halfway, 4,5. I hope we are in agreement. 4,5, that's midway. We are not told about the rest. We are told that he withdraws the money here. Okay, so what we are interested in is what amount of money does he have? Yeah, that's the accumulated amount. We want to know because we know he withdraws, but we don't know what is the amount he withdraws. So we are saying here now, using a timeline, determine how much he will have to spend on his matric dance. Okay. So we need the A value at 4,5 years. That makes sense. Okay. So now I need you guys to listen to me and listen to me very well. Very, very well. You see this 200 rand? We are going to say A is equal to P1 plus I to the power n, just so that we know that this is a compound interest related problem. We want A, so we are going to say A is equal to, now please guys, let's look at the first deposited amount, 200. This 200 is going to enjoy this interest rate. Let's just look at the 200 alone. How long is this 200 going to enjoy the interest rate? Because we need to check the 200 rand. How long is it going to enjoy this interest rate? This is the only interest rate that there is, and it's compounded monthly. So for how long will it enjoy the interest rate? From T0 to T4,5. That means 1 plus 0,085 over what? 12 to the power what? N, remember, that will be 4,5 times 12. Are we together here? The number of years times 12, which is the compounding period. That is our first bracket, because we have to check this 200 rand. How long will it enjoy this interest rate? For 4,5 years. Okay, there it is, times 12. The interest rate, which is 0,085 divided by 12. Then we move on to the next amount that is added, which is how much? We say plus. Why are we saying plus? Because this is the amount that is added at T2. So we add that amount, 550. But we check how long will it be enjoying this interest rate, this 550. It's going to enjoy the interest rate for 2,5. So that means it's going to enjoy that interest rate for 2,5 years. So we take that interest rate, 1 plus 0,085 divided by 12 to the power what? 2,5 times what? 12. That is the 550. That is done. Now we move on to the 350. Where is this 350 inserted? It's inserted at a T3. How long does it enjoy the interest rate? It's enjoying this interest rate for how many years? For 1,5 years. So we're going to say plus. Why are we saying plus? Because this is an addition to the investment. It is an addition to the investment. It's a deposit into the investment. So we are going to add that amount, which is what? 350. And then the interest rate it enjoys for how long? So the interest rate it enjoys is for 1,5 years. So we say 1 plus the same interest rate, 0,085 divided by 12 to the power what? To the power 1,5 times 12. Then one more, we add what? 200. How long does it enjoy the interest rate? For 0,5 years. So we are going to say plus 200, 1 plus 0,085 over 12 to the power what? 0,5 times 12. There it is, guys. So all of this, we just punch all of this into our calculator one time. Just one time. 200 into 1 plus 0,085 divided by 12 to the power 4,5 times 12 plus 550 into 1 plus 0,085 divided by 12 to the power 2,5 times 12 plus 350 into 1 plus 0,085 over 12 to the power 1,5 times 12 plus 200 into 1 plus 0,085 over 12 to the power 0,5 times 12. You put that into your calculator, you say equal, you tell me what answers you guys are getting for this calculation. Okay, shouldn't be that difficult. So guys, whenever you are having an amount added into an investment in your timeline, you must calculate, you must check the interest added into the account, okay? And you must check how long did that particular amount, when was it added and for how long does it enjoy the interest rate. This will help you with counting the years, and then obviously you times it by the compounding period. The years, you times it by the compounding period. The years, you times it by the compounding period. The years, you times it by the compounding period. When you add a value, you write plus. It's the same thing if I was subtracting that value. I would still check for how long would that value that I've subtracted, how long would that value that I've subtracted withdrawn, how long would it have what? Would it have stayed into the account? Because I need to check that interest rate that it would have made, because I get charged, for that by the banking institution whenever I decide to withdraw an amount, sort of like midway into the investment period. So these are important things, guys, very important points, that assist us in formulating our timeline and ensuring that we don't miss no detail. So does anyone have the answer for me that comes out from this calculation? Seems like we're very quiet, very silent, no tabs, no nothing. Everybody's like looking on, and I don't know if it's just confusion, misunderstanding, or is this very clear, guys? Very silent in the comment section, no answers, nothing. It's like everybody is like, I don't know if they are baffled, if they are lost, confused, or if there's anything. No one is saying a word. No one is saying a word. Calculator answer, guys, what did you get? What grade? It's grade 11. Grade 11. Grade 11. Any what answers did you get, guys, for this? 200 into 1 plus 0,085 divided by 12 to the power 4,5 times 12 plus 550 into 1 plus 0,085 divided by 12 to the power 2,5 times 12 plus 350 into 1 plus 0,085 divided by 12 to the power 1,5 times 12 plus 200 into 1 plus 0,085 over 12 to the power 0,5 times 12. What is the final answer that you guys get? Silence. Silence. Thank you, Samantha. Wow, I was beginning to say that Thank you, Samantha. Samantha, if I had something, I would give it to you. It was very good. Thank you. Okay, so hopefully, Samantha, I trust, because I know when you make sure you round off very well, and you spruce up, you do the things that need to be done. Thank you so much. Very good, very well done. 5,155 rand 32 cents. Hopefully we all concur, we agree, we are all on the same page. Okay, right, let's check in another question, guys. These are financial maths questions. As I had said, you guys wanted financial maths, I'm giving it to you for grade 11, guys. Mr. Tlhotlhoza put away X rand at the beginning of January. Okay, at the beginning of January in his grade 8 year. The bank gives him 8.2% per annum compounded monthly for grade 8 and 9. The rate changed to 8.4% per annum compounded annually for grade 10 and 11. If Mr. Tlhotlhoza had 2,150 at the end of grade 11, calculate the value of X. Okay, let's read this one more time. Mr. Tlhotlhoza, it seems like Mr. Tlhotlhoza is very famous. All right, Mr. Tlhotlhoza puts away X rand at the beginning of January in his grade 8 year. Okay, let's go and follow suit with our timeline so that our timeline can serve us very well. T0. So Mr. Tlhotlhoza puts away X rand. Okay, X rand at the beginning of January in his grade 8 year, right? The bank gives him 8.2% per annum compounded monthly. So we say 0.082 over 12, because we are told the bank gives him 8.2% per annum compounded monthly for grade 8 and 9. So for grade 8 and 9. Okay. The rate changed to 8.4% compounded annually for grade 10 and grade 11. Okay. T2, T3. Grade 8 and grade 9, grade 10 and grade 11. So we are changing interest rate here to what? The rate changed to 8.4%. 8.4% means 0.084. But remember, they are saying compounded annually. That means once a year. Okay, remember, compounded monthly means 12, and then compounded annually means 1. All right, so we could have just written 0.084, because if we divide that by 1, it's still 0.084. If Mr. Tlhotlhoza had 2,150 at the end of grade 11, calculate the value of X. Okay, for grade 10 and grade 11. If Mr. Tlhotlhoza had 2,150 at the end of grade 11, calculate the value of X. End of grade 11, 2,150. Can we agree? Right? Remember, this is the beginning of grade 8, beginning of grade 9, beginning of grade 10, beginning of grade 11, if that makes sense, guys. Right? So this would be the end of grade 11. Okay, so what we are being asked here is it oh man, who's this? Who's saying high school used to be so fun? Brandon Finesse. Neat. What course are you doing, buddy boy? Which course are you doing there? Be nice to know what course you're doing. All right, guys, so that means that this is our interest rate compounded monthly. That's for your actual science. Oh, nice, man. Nice. What year are you doing? Let me follow you. I'm gonna have Brandon Finesse. Please follow me back, and maybe we can in future have you're doing your first year. Okay, nice. Yeah, I actually have a kid who last year got 100% for maths, who's actually there doing actuarial science at Wits University. So yeah, great course. I had a boy who did actuarial science like when I first started teaching, and he's like a qualified actuary. So he's done everything, man. He actually works at First Rand Bank, and he's just having the time of his life. Like, he's just living the life. He finished that course in record time, 3 years. Then he did his honors, the whole board exams, and now he's just living it up. So hope that's motivation for you. If you're doing it at UCT, everything of the best. I actually have another young man who's actually also coming from this side, who was studying at a school where a particular program that I was working at, and he's also doing actuary at UCT. I think he's doing his 3rd year this year. I should be finishing off this year, actually. So okay, Buddy Sachs seems to be disagreeing that the answer is 5,155 Rand 32 cents. What did you get, Buddy Sachs? Okay, because the thing is, no one else responded. I don't have a calculator, so I'm trusting what you guys wrote. What did you get? Maybe Buddy Sachs, you can tell me what you got. What did you get for this one? 200 into 1 plus 0.085. Guys, can you confirm this? Buddy Sachs got 1,500. Dogozo got 1,578 Rand 57. Okay. Seems like we've got answers that do not agree with each other. Okay, 1,578 Rand 57 cents. Could it be that someone did a typo? But sir, I did send the answer. But Buddy Sachs, I didn't see your answer. You might have sent it, but it did not appear in my comment section at all. I'm going through my comments right now, and trust me, it did not appear. Was it the same answer as Ndogozo's answer, 1,578 Rand 57 cents? Could you just confirm that? Because these are two different answers. This answer and this answer are nowhere close. Remember, guys, it's not 45. It may have happened that, I don't know, maybe Samantha, is it possible that you may have said 45? This means this is 4,5 times 12. And it's 0.085, so it's 2,5 times 12 as well. That's 1,5 times 12, and that's 0.5 times 12. Okay, so if for some reason someone may have said 25, you imagine how that changes the answer completely, and that's where the danger is. So just make sure that you inserted your values correctly and there were no errors, you see? And that's what we need to double check. Guys, someone, another experienced maths teacher that I actually really look up to, that I've had the privilege to work under, he actually reiterated to my matric learners, in general to all matric learners, that whenever you do financial maths problems, make sure to insert, everything in your calculator, then you say equal, then do it, retype it again on your calculator. Or in actual fact, you could use your back and forth cursor keys to just basically verify and check if all the values, every single value, you've actually inserted it correctly. Because it's so easy when you are typing in something like this to make a typo error on your calculator, and then that basically affects your entire answer. So are we in agreement then that this is the answer, as opposed to the 5,155 Rand 32 cents? Is that correct? Okay, Financial Maths Grade 11. Hopefully we're all in agreement. Okay. Because if we are, then I think we can proceed, right? Okay, so it's not this one, but it's that one, 1,578 Rand 57 cents. Seems like two people are in agreement. I'm trusting, guys, that this is the one. Okay, I'm trusting. I hope Samantha is not too angry with me. Samantha, did you check again, retype in your calculator and just verify if this is actually the right answer? Because maybe if the error was there, then we can actually rectify that. Okay. Oh, thank you so much, Samantha. Okay, verified. Okay, guys, this was a error, but it's a good error. For the purpose of teaching, this is a good error. because it becomes a learning moment. Just like those who wrote 28 for this one, that's a learning curve for all of us, right? That we need to be cautious of our rounding off. When we are cautious of our rounding off, that will ensure that with the 15 marks that is allocated for financial maths in an exam paper, we are making sure we are getting all the marks. Also, making sure that we retype or reinsert all of our brackets and all of our stated things there so that we can just verify our answer is also important. Okay, let's come back here, guys. We wanted here now to calculate the what? Remember there it said Mr. Shoshola puts away X rand at the beginning of January in his grade 8 here. The bank gives him 8.2% per annum, compounded monthly for grade 8 and grade 9. And then the rate changed to 8.4%. Remember, no problem, Samantha. No problem. It's a good error. Okay, the rate changed to 8.4% per annum, compounded annually for what? For grade 10 and grade 11, right? So if Mr. Hlahloza had 2,150 at the end of grade 11, calculate the value of X. So it's very easy now. Yeah, very easy now. What we are going to do is we are going to calculate, using our timeline is already there. We know the interest rates. Remember, this particular value that we don't know is going to enjoy the interest for how many years? 2 years, right? So we are going to say 2 times 12, which will give us 24 there. And then remember, that same amount is going to enjoy the interest rate of 0.084. All right, remember, for how many years? That's going to be 1, 2. That's also 2 years. But remember, this 2 years is going to be multiplied by 1. Why? Because remember, we are compounding annually, not and annually means once, right? Whereas compounded monthly means 12 times. Okay, so this sets us up very nicely for our substitution. So what we then do is R X rand, which is what we want, is 1 plus, remember this is 0.082 over what? Over 12 to the power what? 2 times 12, we just write that 24 directly because there's no need, because we already know that it just makes life easy. Then remember, that same amount is not just only going to enjoy this interest rate, we are the same amount, which is why we just multiply with another bracket. We say 1 plus 0.084. The same amount is going to enjoy this interest rate, which is 0.084, compounded annually. Okay, yeah. And then remember, we have A. Where is A? A here is 2,150. Okay, because we are actually given, we are told there, if Mr. Hlahloza had 2,150 at the end of grade 11, calculate the value of X. So we want to know what is the amount that Mr. Hlahloza invested to begin with. Okay, so 2,150, we know that's the amount that we have at the end, the accumulated amount at the end. So now we are going to calculate that. So what do we do here? Guys, it's very simple. What we do here, we are going to divide both sides by what? By 1 plus. Okay, we are going to divide both sides by these 2 brackets. Okay, and that means those 2 will cancel, and then we know that Rx rand is simply going to be 2,150 over 1 plus 0.082 over 12 to the power 24 into 1 plus 0.084 over 1 to the power 2. So it's a matter of putting all of this into the calculator. Of course, you could write this as brackets with negative exponents, which will be next door 2,150. You could do that as well. But I mean, it's one and the same thing. Okay, you could just say 2,150 divide by these 2 brackets. And then please let me know what you get as your answer. What do we get? In rands, what is the value that we get? Oh, buddy. 1,553 Rand 81 cents. Okay. Done. Dusted. Okay. Not too bad, was it? Hopefully all of us got that. Ntokozo, yes, confirmed. Ntokozo, really appreciate it. Good job. Okay. Guys, see that? See these problems? Very nice. Very nice, very nice, very nice, very nice. So timeline. Timeline is not bad. Timeline, all it needs is that whenever you have these amounts, you just need to check how long is an amount enjoying, which interest rate is that amount enjoying, how long. Okay? Is it 9 marks? Sean Babs, this one, it's not 9 marks, this one. This one is 5 marks. I mean 4 marks to be specific, not 9. It would be too much. 9 marks? Hey, when you want marks to be given away, just like that. Okay, let's look at this one. Question 3, all right, and then we'll do question 4, and that will be that, guys. Call it a night. After that, I have to go sleep as well. I can't really stay up for long, so unfortunately, I'm not going to be able to have the session that I was intending to have, but hopefully the grade 11s will feel very satisfied that I was able to assist them as much as I did, and yeah. Befile is considering a loan to pay for his university study fees. Some of you are going to be considering such loans. Why? Because you guys won't want to get the maths marks that will ensure that you get a bursary. So you are going to have to consider taking a loan because you don't have the marks, guys. KB, I wasn't going to do grade 12 today. I told you guys that, okay? Yeah. Please, please, please. I told you guys I'm not going to do grade 12 today simply because why? It was not budgeted, it was not planned for. I planned for grade 11, but I can definitely have a future session with the grade 12s with financial maths. But for now, today, it's grade 11. That's what I planned. So you guys are, please, you need to forgive me there, and you need to be merciful because, yeah, as I said, please, I am not the only avenue for learning mathematics. I know you guys have your, I know mathematics kids will tell you about Miss Martin. If you want to know, go to Miss Martin, you're right? Go to Miss Martin, you can go there. She's there, that woman, doing amazing stuff, YouTube. You can go to Kevin Maths and Science, amazing guy, doing all sorts of things. Okay, bigger look, obviously. When you are the one that's getting the high marks anyways for maths, so you should be feeling everything as is. Yeah, you have Mlungi Sinkos, you have all these great people that have been on platforms for years, and even me, my intelligence bows down to those guys. They've been doing the most, you know. And then you have Mafikizolos like us. Hi, party sex, man. Befile is considering a loan to pay for his university studies of 45,000. Okay, so guys, we need to work very hard here in grade 11 so that end of year we have the marks that will ensure that we don't find ourselves in sticky situations where we have to cough out money like this. The bank offers him 9.5% per annum compounded quarterly. That's what the bank offers him. He's going to pay for the money off in 5 years' time. You see, convert the given nominal interest rate to an effective rate per annum. That is what is the key about this thing. Your nominal interest rate, all right, is accompanied by a compounding period, whereas your effective rate is the annual rate. It's the annual rate. So you say that's why they're saying convert the given nominal interest rate to an effective rate per annum. All right. And remember, when you apply the nominal interest rate, you know, it would be equivalent to the effective rate per annum, you see. So you are actually wanting to get an equivalent rate that will actually be offered per year that would be equivalent to this nominal interest rate of 9.5% per annum compounded quarterly. So remember, do you remember the formula that we use to convert nominal and effective to nominal? Very simple. 1 plus I EF, okay, is equal to 1 plus I norm over what? Over M to the power M. Okay. Now, 1 plus I effective. Now we substitute 1 plus I. I norm is the interest rate, that is the nominal interest rate, which is 9.5%, but we want to express it as a what? As a decimal. So we are going to say 0.095 over M. Now we are asked that it is compounded quarterly. What does compounded quarterly mean? It means we are going to divide by who, guys? If we are compounded quarterly, we are going to divide by what? By 4. Okay. Grade 11 learners divide by 4. Okay. And then M to the power 4. Now we want to get the effective interest rate. So it means we need to isolate the effective interest rate, or make I effective the subject of the formula. To do that, I effective is equal to, take the 1 over, we transpose it, so it's going to be 1 plus 0.095 over 4 to the power 4 minus 1. You take your calculator, you punch all of this in. You punch it all in, guys, all of it. All of it. All of it. And then you tell me what you get. Tell me what you get as a decimal number, and please give me with all the digits to begin with. All right, because I want to do something after. Give me all of the digits that you see in your calculator. All right, up until the end. So when you type your answer, please type all the digits that you get as your decimal numbers at the end, please. One plus 0.095 over 4, all raised to the power 4, and then you have your minus 1 outside the bracket. What do you guys get as a decimal number? Please give me all the numbers after the comma that you get. So the entire decimal, that's what I want basically. Minus 1 comes there after the bracket, the entire bracket. That's where minus 1 comes in. 0, and it's coming from this one. This one got transposed over to the other side. Are you with me? So it's 0.09843827791. Thank you very much. So what you then do, guys, is you are going to write R effective. Okay, please, guys, you are going to write R effective. Why am I going to write R effective? Because remember, this is the interest rate expressed as a decimal. When you want the interest rate expressed as a percentage. So that means, what are you going to do to this decimal number? You are going to multiply it by what? By 100. When you do that, simply moving the decimal twice, 1, 2. So it's 9.84. Cut off the comma there, the line there. It's 9.84. Rounded off to 2 decimal places, so it's 9.84%. Okay, I hope you are with me there. 9.84. So that's, and then I write R effective, because guys, remember, this is always going to be so important for you to note. Oh, Olivia, nice. You're nice. You're writing a nice topic. All right, so that means I think in 2 days' time, I'll do Euclidean as well. We'll look at some Euclidean problems, okay? But yeah, enjoy the Euclidean. What do you mean not nice? Euclidean is such a beautiful topic. Where were you in my live session when we were doing Euclidean? You then, Livia, you should definitely go to my YouTube channel. There was someone else who just commented on that video. It's funny that my videos, obviously I understand that maybe the quality of the videos that I upload, since they come from TikTok, are not as great, but someone actually commented in the video that I just uploaded for Euclidean geometry in the YouTube channel just not so long ago, and was really grateful, yeah, for that live lesson we once did, where I think there was a student that was asking about it, and I did a kind of like a summarized review, very long, but very much worth it. Yeah, then I came at the last week, so I was probably sick.
I wasn't okay for the first week, so I was probably sick during that lesson. Oh, snap. No, guys, Euclidean is nice. If there's anything, Euclidean is very nice. It's very, very nice. Okay, I will dedicate some time and do Euclidean with you. We'll start with the grade 11 Euclidean. Okay, so for instance, Livia, tomorrow when I do the live, I'm going to do Euclidean. I'm not even gonna do financial maths. I'm gonna do Euclidean for you, all right? For you. So join me there at 8:30. What is it? 8:30. What is it? Let's try 8:30. 8:30 tomorrow. Yeah, let's try it. Okay. Yeah. At least when you've been a loyal viewer, so I have to. Yeah. You must know when you're a loyal viewer, your special things get done. Someone who I will probably just be loyal for days would be Mrs. Him. Mrs. Him has been like very generous to me in my life, so I'll definitely be super loyal to her. No doubt. Okay, so that's the nominal, guys. This is the effective. So we must make sure that we okay. Yeah. Okay. So let's go to the next question, 3.2. In total, what will he have to pay at the end? Body sex, that's a good idea. Just create your own song in Euclidean of all theorems, you'll master them. Did you guys see the one colored teacher that actually did a song on all the theorems? That was actually quite good. I thought that was good. Unfortunately, I don't have a song for the Euclidean geometry theorems, but definitely very important to understand the theorems and their diagrams if you want to master it. Okay, in total, what will he have to pay at the end of the 5-year period? Okay, in total, what will he have to pay at the end of the 5-year period? Okay, so remember, you were told that Perfile is considering a loan to pay for his university studies of 45,000. The bank offers him 9.5% per annum compounded quarterly. He's going to pay the money off in 5 years' time. Now we are being asked in total, what will he have to pay at the end of the 5-year period? Okay, and that's what's brutal, guys. Loans, when you take them, they are brutal. Okay, because remember, if you take out a loan of 45,000 after 5 years, if we apply the interest rate, okay, that particular interest rate, what ends up happening is that you end up paying more than the 45,000 back. So let's check in total, what will he have to pay at the end of the 5-year study period? In total, what will he have to pay at the end of the 5-year study period? So let's check this out. So what do we do? Obviously, we're going to use the compound interest formula. Okay. In total, what will he have to pay at the end of the 5-year study period? So the 45,000, we'll take it as our p-value. All right, and then we will check. Okay, now you can either do one of two things. You could either apply the 9.5% per annum compounded quarterly, okay, all right, or you could use the effective interest rate, which is 9.84%, and just apply it without compounding quarterly. You will get the same amount at the end of the day. All right, same amount. But okay, let's just be direct and just use what we've been given here, the 9.5%, because it makes life very easy, if you know what I mean. So we can say A is equal to P 45,000. 1 plus the I. The I is actually 0.95 over what? Over 12 to the power what? 5 times 12. Yeah, I can make life easy like that. 5 times the 12. What do you guys get? How much will this guy have to pay at the end of the 5-year period?
Okay, you take out a loan of 45,000. How much will you have to pay at the end? So I'm waiting for you guys to tell me how much. Come on, guys, come on. I trust in you, I believe in you. How much? How much will you be paying? 45,000. 1 plus 0.095 divided by 12. 5 times 12, which is 60. What? How much? So this is a nice 3-mark question. In fact, both of these are 3-mark question. Formula, substitution, answer. Formula, substitution, answer. You know, it's like those formula, substitution, answer. Make sure you round off to the correct decimal place. Do I still have people here? Or have all my people left? Because honestly, I'm like waiting for the answer. No one is giving it to me. Oh, thank you, Ndogos. You're such a star. Ndogozo is such a star. Thank you so much. Yeah, Samantha as well. 72,225 Rand 43 cents. So that is basically what you'll be paying back. Imagine. Okay, 3.3. Another bank offers him a different rate, compounded monthly. So this is a different bank altogether. So if you're looking at this question, you are looking at another bank offers him a different rate, compounded monthly. Okay, it's another rate. We don't know what it actually is, but we are told it's compounded monthly. If the total amount he had to pay at the end of 5 years with his loan was 76,200, what was the interest rate? Okay, so we have A is equal to P into 1 plus I to the power n. If the total amount he had to pay at the end of 5 years with his loan was this amount, remember this is basically our A value. So we have 76,200 is equal to the P another bank offers him, which means a different rate. If the total amount he had to pay at the end of 5 years with his loan was, so the loan is still 45,000. 1 plus the I would mean I over what? We don't know, over 12 to the power what? 5 times 12, so that's 60. Okay, yeah, so another bank offers him a different rate, compounded monthly. If the total amount he had to pay at the end of 5 years with his loan was that amount, what was the interest rate? Okay, so yeah, so you can see what we've done here. Okay, we need the I value, so we're going to divide both by 45,000. Okay, then we're going to be left with 1 plus I over 12 to the power 60. Then we are going to take what? The square root, I mean the 60th root. Take the 60th root on both sides. So that will allow us to have 1 plus I over 12. Then we're going to transpose the 1. Okay, And then after that, we are going to get the answer, and then we are going to times both sides by 12. Okay. So this is all algebra, guys. This is all algebra. Okay. Then that cancels that. We are left with I. But remember, whatever we get here, and you guys are going to tell me what you get here. 12 times the 60th root of 76,200 over 4,500, and inside the 60th root minus 1. And you get the answer. Okay, 12 times all of this. You tell me what you get as the answer. All of it, guys, the entire decimal. Don't leave a number, okay, at all. Then we are going to actually multiply that by 100 to get the R, the interest rate, okay, as a percentage, because we want to know what the interest rate are, okay, specifically. So you first need to give me the decimal with all the decimal numbers, and then I'm going to multiply that by 100 to get my R, okay, rounded off to 2 decimal places thereafter. So I hope you guys understand the maths done here. 45,000 is multiplied to all of this. So you start with the 45,000, you divide both sides by 45,000. So if you divide by 45,000 here, it disappears. You're left with 1 there. And after doing that, you are going to take the 60th root. Why do you take the 60th root? To get rid of the 60. But what you do on the right, you do on the left. So you are here. Then that makes that to the power 60 disappear. Now you have the 1, you transpose the 1, that becomes the 60th root of this fraction minus 1. Okay, then after that you are left with I over 12, but then you have to times by 12 in the numerator to get rid of the 12 in the denominator. Then you are left with 12 times all of this. You get the answer as an interest rate, as a decimal. So that's called algebraic manipulation. And I think really and truly most students who are unable to get to the value of I here like this simply struggle with algebra. So that's why we need to make sure that we iron out, or we sharpen our algebraic skills, so that we don't find ourselves falling short when it comes to actually getting to the answer. So I hope you guys understand what I did step by step, that there's no issue, challenge, or concern. If there is, please let me know so that I can address it or help clarify it for you. Okay. So, Ntokozo, such love. Man, Ntokozo, you're the best. Do you know that? You're the bestest ever. Okay, then what I'm going to do, I times this by 100. When I do, I just move the decimal twice, decimal place twice, 1, 2. So it's 10,58. And obviously after the 58, there's 0.3, so that does not change anything. I stay the same. So that means I have 10,58%. Sure, rockstar per annum, compounded monthly. Does that make sense? Ntokozo, you're a star. Akhona Ntokozo, thank you so much. You are much appreciated. I appreciate you a lot. Ngiyabonga, ngiyalebucha. Akhona. Okay. Right, I think I am at my last few questions. Right. Let's look at the last few questions because they have to do with the formula that I have not yet really looked at. Okay, we've looked at nearly all the formulas excepting the following. So let's check the last few questions. Okay. Miss Mugu's car depreciates at 15.2% per annum. She bought it for 175,000. Okay. Miss Mugu's car depreciates. So now we are in depreciation. Depreciates at 15.2% per annum. She bought it for 175,000. Calculate the book value of the car 4 years after she bought it. Calculate the what? The book value of the car 4 years after she bought it, if it is depreciating on a reducing balance. Keyword, reducing balance. Right now, guys, there are two formulas, remember, when it comes to depreciation. But the minute they say reducing balance, that means you know exactly which formula to use. Now, guys, very important, because there's always a misconception when it comes to the formula that we use, and it's very easy to fall into the trap of thinking it's 1 plus, whereas we are not talking about values that, appreciation or increase, but we are talking about a loss in value. So Miss Moku's car depreciates at what? 15.2% per annum. So she bought it for 175,000. So that means we know that the principal amount was 175,000. 1 minus I 0.152 over what? Oh, we don't have a compounding period. Okay, so if we don't have a compounding period, then obviously we are told it depreciates at 15.2% per annum. Okay, that's every year. Then that means basically if we have just 4 years, okay, times 1, okay, because obviously that's just it. And we take our calculator, we substitute, we should get the answer. 175,000 into 1 minus. Remember, I didn't have to necessarily write that 1 in the denominator. I could have just written 1 minus 0.152 to the power 4. So what's our answer, guys? What is our answer for Miss Moku's car? She bought it for this much. What is the book value? Remember, after some years have passed, this is the value of the car after some years have passed. Does it roughly cost? Can someone then can Miss Moku make a profit if she was to can she at least make a reasonable amount of money if she was to sell the car, given its depreciated value? Come on, guys. Come on. I'm waiting patiently for the answer. You are my only hope, you are my only hope, you are my only hope. You give me hope, my only hope. Okay, thank you, Ntokozo. Ntokozo is continuing to be a rock star. Thank you so much, Samantha, as well. Yeah, you guys are spot on. 90,494 and 35 cents. I'd say not too bad, eh? After 4 years, not too bad. Then the next question is, what would the rate of depreciation be if it is worth the same amount after 4 years, but depreciation was on a straight line basis? Let's look at this. What would the rate of depreciation be if it is worth the same amount after 4 years, but depreciation was on a straight line basis? Now they're saying, what would the rate of depreciation be if it is worth the same amount? So that means our A value is still 90,494 Rand 35, whereas P is actually equal to 125,000. So let's check this out. 90,494 Rand 35 is equal to 175,000. 1 minus IN. IN, remember the N is 4 years. So say I times 4. Okay. Then after that, what are we going to do? Divide both sides by what? By 175,000. So 90,494 and 35. Divide by 175,000. 1 minus I times 4. Then it's very easy. Transpose the 1. 90,494 over 175,000. We subtract the 1, we have negative 4i. Take your calculator. Okay, remember you take the 1 over. Remember, we first divide by 175,000 both sides to get rid of this 175,000. Why are we doing that? Because we want to isolate I. Then we take the 1 over, we transpose it. This one, it is positive, changes to negative. We're left with negative 4i. Then after getting that answer, we are going to make sure we divide both sides by negative 4. Trusting you have done that. You divide all of that by negative 4. Then you're left with I. So I want to see what you guys get. 90,494 Rand 35 cents, comma 35 over 175,000. Then you subtract the 1, the fraction, and then you get the answer. You divide by negative 4. Tell me what you guys get. The decimal, everything. I is equal to, then I'm going to multiply by R 100 to get the R value. Okay, we're very close, guys, to finishing. Just hang in there. Gonna be done right now with the financial maths. Okay, you guys have been real troopers. You've held on, you've hung on. Divide by negative 4. 90,494,35 divided by 175,000. You subtract the 1, you get the answer. After that, you divide by negative 4. You should get the answer, guys, for I. And then I will multiply the I by 100 to get the actual percentage, which is the interest rate. And that's very important. Okay. Okay, we have differing answers. We have different answers. Ndokoza 0.12, and then Samantha is in 0.984. So, or is it from the previous? Is this? Oh, okay, nice. Okay, now slight deviation in the decimal. So who's who? Okay, you look at 0.1. It would still be both 12.07, but you guys have slight deviations in your decimals there at the end. Togo has 3571 at the end, whereas Samantha has 9286. Either way, 12.07 wins the day. Percent per annum. Okay, that would be depreciation. And the wording, straight line basis, straight line method. So sometimes they say basis, sometimes they say reducing balance method, reducing balance basis, straight line basis. Let's understand the formula. And you see the choice in formula when that is said. A is equal to P1 minus I times N, because it's straight line basis, as opposed to reducing balance method. Okay, guys, I think I'm gonna hold it right there. Okay, that was a meal and a half. Hope you guys enjoyed my meal. It was good, and that you guys really pulled stops. So just as a recap, what did we do today? We did financial maths, grade 11. What specifically did we do or cover in financial maths today? What we did is we first looked at simple interest. We defined what simple interest. We looked at an example so that we could understand the concept of financial maths as it relates to the fact that interest is calculated based on the original amount for every year, which means our investment is always increasing by a constant amount. Hence, simple interest, related problems can be represented in graphical form as a linear function or a linear graph. Okay. Then we were able to check how do we calculate how much interest is paid in an account, especially when we have accumulated it over a few years. We want to check how much did we actually make, by how much did the account grow. So we were able to see that for simple interest we can use these two formulas, or we can just simply take the accumulated amount minus the principal amount, which is what you can do for compound interest as well. Then we looked at compound interest. We looked at how it is actually calculated based on the previous year's accumulation. Every single year we calculate 10% or that percentage interest rate of that previous year's amount, and we add on that value every single year. Hence, when you compare the two, you can see one is linear. So at the beginning they might start off the same, but at the end it's almost like the exponential function takes off. Okay. Then we looked at compounding periods. How when we've compounded annually, it's once a year. Compounded biannually, semi-annually, half-yearly, it is twice a year or every 6 months, but twice is more specific. Quarterly, every 4 months, but we know it translates to 4 times a year. Daily means 365 times, but if we say we're told including the leap year, it's 366. Weekly is 52 times, and monthly is 12 times a year. Then we saw that when compounding periods influence your compound interest formula, this is how we see it manifest, visually. Then we looked at depreciation, okay, because with the compound periods, we divide the interest rate with the compounding period, and then we multiply the number of years with the compounding period. Depreciation, we looked at how it's loss of value. We were able to see that book value is the value of an item after a certain period has passed, as like we just looked at an example with the car. Scrap value is the value of an item after when it's no longer useful, right? That particular item. Then we looked at 2 types of compound of decay or depreciation, simple decay or straight line method, right? In that problem, we also learned that they could say basis instead of method, or they could say reducing balance method, compound decay, or the likes. Then we saw that graphically, your straight line method represents a linear graph, whereas which is decreasing in nature, but then your compound decay represents an exponential function, which is also decreasing in nature. Then we looked at the effective and in nominal interest rate. How do you convert effective to nominal? If we are given nominal and its compounding period, how do we convert nominal when we are given the interest rate? That we need to know how to do as well. Then we looked at examples, or let me say test type questions, where we had to use the timeline, not once, but twice, okay? We looked at questions referring or related to effective and nominal interest rate. We looked at compound interest related problems where the compounding period comes into effect. We looked at how to find the value of I, the interest rate, when we have a compound interest situation, but also we have to factor in the compounding periods. And then, because we want I, basically make I the subject of the formula after substitution and algebraic manipulation, which we need to know very well. We also were able to touch on the fact that rounding off is important. We need to take note that when we round off to the accurate decimal place without necessarily making big errors. Then last but not least, we looked at reducing balance type question with a straight line basis type approach and application. And ultimately that wraps up our grade 11 lesson for today with the types of questions that we ask. So hopefully you walk away from this live session having gained something, and may it add value, especially to the grade 11s. Grade 11s are, you guys must make sure that you do the things that ought to be done. Dogozo, thank you so much. Thank you for joining, and thanks for your very active participation in the comment section and making sure that when calculator-related questions required your punching skills and your delivery of your answer in the comment section, you are very proactive and very visible and very amazing. So thank you so much, Akwan. You've been really phenomenal and quite a star, if you ask me. And even with Samantha as well, I really appreciate you, Sissy, always showing up and just, I don't know, always just such a humble spirit, such a humble soul, always willing to participate and answer. So hopefully then now the financial maths we've covered. I will upload the video in the YouTube channel just shortly. I'm going to try and download it and upload it. So if you've missed it, you can watch it and check out the financial maths and just make sure that but also remember, your part is to make sure, since you've understood now, you go and practice some questions, grade 11 related questions on financial maths, and just make sure that you close the gaps for yourself. Because term 3 guys for grade 11s, we need to make sure that we are getting those marks that we deserve, not the marks that we don't deserve. Otherwise, thank you so much for joining in again. Hello Presh, if you are really there in the comment section. I think I just saw you slide in there. That's if you're still there. But otherwise guys, thank you again. Have a good one, and please sleep well if you are sleeping. If you are still pushing night sessions, then everything of the best with pushing night sessions, and see you again. Okay, bye.